Hello, this video is on Newton's first law, the easiest of his three laws to interpret. So, a body, if stationary, if still in other words, will remain stationary or still, or if moving, will continue to move in a straight line at a constant speed unless acted upon by a resultant force. So in other words, things don't just accelerate away on their own course, or things don't just stop. A force, a resultant force, must be acting upon it. So let me make some diagrams to help us understand this, or rather help you understand it. Me as well. Every time I do these things, I understand them a bit more. So here we have an object at rest on the ground, say. Forces acting on it will be its weight, mg, and the equal and opposite force acting on it, which is the reaction force to the contact force, often known as the normal force acting at 90 degrees to it. And the magnitude of R will equal the magnitude of mg. There is no resultant force, therefore there will be no change. It's not going to start moving. Another example, now that has got a velocity of 0. Another example could be a car. I'm going to draw a car, not very well, but I will do my best. I'm getting better at these things. Well, maybe I'm not getting any better. So here we have a car, and let's put some ground on it. And let's assume it's not a hover car. Let's get the wheels touching. So here we have a car resting on the ground. And let's say that we have, say it's in equilibrium in the vertical position. The reaction force is equal and opposite to its weight. And let's say also that it's moving at 40 meters per second. Now, it can also be in equilibrium. So, for instance, if we had a thrust of, say, 8,000 newtons, and we had an equal and opposite resistance of 8,000 newtons, it would not be accelerating. So it will be continuing to move in a straight line at a constant velocity, thus following Newton's second law. Now, if suddenly the guy puts his foot down on the accelerator and adds another naught to there, so 80,000 newtons, wow, that's a hell of an acceleration. So suddenly we've got unbalanced forces, it's accelerating, and we're no longer following Newton's first law. There is a resultant force on there of 80 minus 8, which gives us a resultant force. Resultant force is equal to 72,000 newtons, and that will produce an acceleration.